Nuclear war is the end of humanity. Over the decades of the Cold War between nuclear powers threatening to turn the world into ashes, this has become almost an axiom. And yet, the parties were looking for a solution: how to destroy the enemy and avoid a catastrophic retaliatory strike. And it seemed they had found it. A sudden and rapid nuclear attack would destroy the enemy's command, and there would be no one to press the button, and the disoriented strategic forces would not have time to adequately respond, and would be destroyed. And then, when success is almost within reach, the winner meets his end. Capitals, headquarters, and control points are destroyed, but the missiles are still launched under the control of a system whose only task is revenge. In the ashes of a nuclear apocalypse, the dead hand will do its work. Plans for decapitation strikes appeared at the height of the Cold War back in the 1950s, and became increasingly relevant with the development of technology. The emergence of medium-range missiles and submarine-launched missiles that could reach their target very quickly. Strategic parity meant equality between the USSR and the USA in nuclear forces, and the strategists developing such plans understood perfectly well that their colleagues on the other side of the barricades were doing the same thing. If you create a poison, you need to create an antidote. The solution to this problem was to create a second bottom in the chain of command, a kind of parallel autonomous system capable of launching a retaliatory nuclear strike, even if it was impossible to give the main orders: the death of command, disruption of transmissions, and the breakdown of communications. In the United States, such a system appeared quite quickly, back in the early 1960s. The ERCS, or Emergency Rocket Communication System, was a communications complex that was supposed to ensure connection between all components of strategic forces, even in the event of loss of main infrastructure. In addition to duplicated landlines of communication and doomsday aircraft, the system included special missiles. They were created on the basis of the Blue Scout and Minuteman II missiles, with the nuclear warheads replaced by powerful transmitters, and in the event of loss of communications were supposed to fly over the bases of the missile forces, transmitting orders for a retaliatory strike. But for the United States, this threat was not so critical, since they could only be suddenly attacked by missiles from strategic submarines, of which there were not many, and which they tried to closely monitor. The USSR had a different picture. There were many US allies near the Soviet borders, and they could serve as lodgements for a surprise attack, with medium-range missiles that could reach critical defense sites, including of course Moscow, very quickly. Moreover, the development of space technology and the implementation of projects such as the Space Shuttle caused serious concerns about the possibility of nuclear weapons appearing in orbit, right overhead. And Moscow began to create its own double bottom. Work on a project which was called Perimeter began in 1974. The concept was similar to the ERCS, but with nuances. Command missiles here played the main role of delivering the final order. The MR-UR-100 ballistic missile, also known as the RS-16B or SS-17 Spanker, was chosen as the command missile. The missile was heavily modified, and instead of a nuclear warhead, a transmitter was installed, powerful enough to deliver a signal under the influence of radiation from nuclear explosions and electronic warfare. With a strategic range of over 10,000 kilometers or 5,400 miles, the command missile could fly along a ballistic trajectory over the regions where the country's nuclear forces were located and transmit final orders. The command missiles themselves were located in standard ballistic missile silos, and it was impossible to determine from external signs what kind of missile was hidden under the cover. At the same time, a communication system was created. Launch silos were equipped with special antennas and control units that could receive signals from command missiles. Later, all nuclear forces were equipped with the same systems: submarines, air bases, strategic bombers, and so on. In the event of a surprise attack, all troops had to recover as quickly as possible. And all of this had to work in parallel with the main nuclear forces control system, and at a very high level of automation. The task was simple, even if the first strike had already happened, even if the command was killed and communications were lost, Perimeter had to strike back. The control system itself is the most secret component of Perimeter, which is why over the years of its existence it has become overgrown with a large number of myths. All descriptions of the system say that it is automated, and the main question immediately arose: how automated is it? The radical answer to this question is a fully automatic complex, a kind of Doomsday Machine, a computer equipped with many measuring and communication systems that can determine the fact of an attack on the country and independently decide to launch a retaliatory strike. In addition, there is talk that the elements of the systems in the silos are also automatic, and upon receiving a signal from the command missile, are capable of launching ballistic missiles independently. Despite all the coolness of such an idea, the fact of its existence is unlikely, and too dangerous. This isn't Skynet, of course. A highly advanced artificial intelligence is not needed here, but even an ordinary computer cannot be completely protected from error. Critics of this idea point out, firstly, the lack of need for total automation. People still have to manage it. Secondly, the reliance on a network of measuring and communication systems is questionable, since Perimeter was originally created specifically for the case of a massive attack with loss of connection, which means that all these communications may not work. Thirdly, launching a ballistic missile is a complex process with many stages that protect against errors, and the idea that a computer, ignoring both procedures and operators, can launch a nuclear missile on its own, sorry, but that's just madness. Apparently, the Doomsday Machine is more of a figure of speech than a real computer. Perimeter really is autonomous and operates independently, but independently of the top command, not of humans in general. In the base, the system operates in a kind of sleep mode and is inactive, but in the event of a threat of attack, the country's leaders switch it to active mode. Launches are not carried out immediately, but they guarantee that if the order to cancel is not received, communication is lost, and measuring instruments confirm nuclear explosions on the territory of the country, the perimeter operators will strike back. Yes, there is a lot of automation, but the final decision is made by a human. This is simultaneously a guarantee that even after a decapitating strike, retaliation will reach the aggressor, and insurance against error. In history, there have been cases of false triggering of missile attack warning systems, and the country's leadership, having activated the perimeter, got rid of the need to immediately launch a retaliatory strike. And another, political insurance. The enemy knows about the perimeter's existence and understands that a decapitating strike does not guarantee victory at all, and therefore the desire to open the nuclear briefcase will greatly diminish. The system was created quite quickly. Already in 1979, missiles and new means of communication between the bases began testing. Test launches of missiles were carried out, and ground systems were tested for operability under conditions of impacts similar to nuclear strikes. As part of the tests, even real missions were carried out. A command missile was launched, flew over one of the missile force's bases. There, the signal from it was received, and the combat ballistic missile was launched, successfully hitting the target. All training, of course, domestically and without nuclear explosions. In 1985, the perimeter complex was officially put on combat duty. In the United States, according to fragmentary intelligence data, it was assessed correctly. There it was given the name Dead Hand. As part of further development, the Dead Hand acquired an additional finger, created on the basis of the Pioneer or SS-20 Sabre medium-range ballistic missiles. The mobile system with command missiles was named Gorn. They were not in service for long, until the end of the 1980s. Looking from our time, we can say that both the American ERCS and the Soviet perimeter did their job. Having become another deterrent, they did not allow the Cold War to enter a hot phase. The Intermediate Range Nuclear Forces Treaty minimized the risk of a surprise decapitation strike. With the end of the Cold War, both systems were put in a passive state, and the ERCS was completely dismantled in 1991 by order of President H.W. Bush, at least officially. In the mid-1990s, the Russian strategic rocket forces retired the UR-100, and therefore the command missiles were also eliminated. However, they did not eliminate the perimeter. The UR-100 was replaced by new command missiles, presumably based on the Topol or SS-27 Sickle B ballistic missile. It is difficult to say how effective the system is now, with the return of medium-range missiles, the emergence of hypersonic weapons, and new missile defense systems. But apparently we can be sure the dead hand is alive and active. Let's hope that it will never have to be used. Subscribe to the channel so as not to miss new videos. There are still a lot of interesting things on the horizon.